Greetings. Welcome to Math in a New Time. My name is Steve Miller. I am a professor of mathematics at Williams College, and I'm with two students of mine, and we're going to be talking about how to get from the Pythagorean theorem to some formulas for pi. And along the way, we're going to review some concepts from algebra, we're going to see some concepts from trigonometry, and we're going to see some fun formulas. So, the first thing is there are many wonderful formulas for pi. Our goal is to derive enough trigonometry to explain them. So for those of you who are now trying to learn math from home, this is, depending on your school district, 10th or 11th grade mathematics, if not college. I am a strong believer in the power and the ability of students to rise to a challenge, and that is one of the reasons why I'm making this. So if you look on this picture right now, you should see that there are many different circles. I don't know if you can see my mouse when I move, but here's a circle, here's a circle, here's a circle. There's lots of circles. You should see at least 5 circles. Now, the circles have two interesting quantities. Can somebody give me a quantity associated to a circle?
It's 360 degrees.
So it's 360 degrees around. What else do you associate to a circle?
It's round.
It's round. So what numbers do you associate to a circle? It's
Radius.
It's radius. So its radius is how far it is, how far it is from the center. So all points on the boundary of a circle are the same distance from the center. And what else do you associate to a circle?
Circumference.
The circumference or the perimeter. How long is the boundary? So the circumference or the perimeter is how long the outside is. What else would you associate to a circle? It's
Diameter.
Its diameter, which is how wide it is. So that's going to be twice the radius. What else? So the circumference is how length it is.
Does it pi has to do something?
It does. And so what else would you associate to a circle? If I give you any object, you might ask for its
size.
Its size, its area. And so the formulas for the circle is that if you have a circle of radius r, its area is pi times r squared, and its perimeter is 2 pi r. Now this is the big thing to notice. If I were to double the circle, what do you think happens to the area? How much do you think the area goes up by?
Double.
If I double the area.
2 times.
So if you had a square that was 1 by 1, and you doubled a 1 by 1 square, what size square would you have?
A 2 by 2.
And what would the area be now?
4.
If you had a 3 by 3 square, what's the area of a 3 by 3 square?
9.
And if you double the sides, what does it become?
6 by 6.
Which is an area of
36.
And it also goes up by a factor of 4. So if you double the size of a square, its area goes up by a factor of 4. If you double a circle, what do you think its area should go up by?
A factor of 4.
A factor of 4. And so what we see here is if you look at the formula, the area is pi times r squared. If I double r, so I have 2r, I would have 2r times 2r is 4r squared. So I would see that the area of the circle is going up by a factor of 4. So the biggest thing we need to do is we need to compute what is the area of a circle of radius 1. And then if I figure that out, then I can figure out the area of any circle because I know how it has to grow. It's the same for the perimeter. I just need to do one circle. And this is where these special math numbers come from. If you have a circle of radius 1, the area turns out to be pi. Does anybody know? I know you know a lot of digits of pi. What is pi approximately?
3.14.
Okay, go on. 3.14.
1592653.
So that's a really good start. And its perimeter is about 2 pi r. Okay, so there's a bunch of formulas for pi. So here is one formula. This is the Gregory-Leibniz formula. This is a strange one. Pi fourths is 1 minus a third plus a fifth minus a seventh plus a ninth minus an 11th plus a 13th minus a 15th plus a 17th minus a 19th. What would be next?
Plus the 21st.
And what would be after that?
Minus the 23rd.
So this is a strange formula. It's the alternating sum of the reciprocals of the odd numbers. So let's try to test this a little bit. So you first determine let's group them in terms of every 2 together. So 1 minus a third, a fifth minus a seventh, a ninth minus 11. So what is 1 minus a third? So you can use your scrap piece. It's 2/3. What's 1/5 minus 1/7?
1/5 minus 27.
1/5 minus 1/7. So you can use your scrap paper.
2/35.
Okay, let's see. And then you can do the next one, but don't say out the answer.
1/9 minus 1/11.
Yeah. And then don't say the answer out loud. Just write it down on your piece of paper. Yep. Yep. And so for the 1 minus 1/3, we make a common denominator, which isn't too bad. For the 1/5 minus 1/7, it's the same. It's 299. So everybody got 2/3, 2/35, 299s. Now mathematicians love looking at patterns. Do you notice anything interesting about the numbers 3, 35, and 99?
They're all
They're all odd.
They're all odd. Are they close to any interesting numbers?
both close to power.
Oh, they're
Not a
They're
power
both
2.
close to a square.
They're both close to a square. What square is 3
They're
close
both
to?
1 less than a square.
4.
4. 35.
They're both 1
36.
less than a square.
Excellent. And 99? So, as you noticed, it's 4 minus 1, 36 minus 1, 100 minus 1. And if you look at the next one, 13 minus 15, you're going to get 15 minus 13 over 13 times 15. And 13 times 15 is 1 less than 14 squared. And so we get this beautiful formula.
Like the number is like right in between, like the 9.
It is right in between.
11.
Just like
This-
4 times 6 is 24 and 5 times 5 is 25. It's right in between. So we can write pi over 4 more concisely as 2 times 1 minus 2 squared minus 1 plus 1 over 6 squared minus 1 plus 1 over 10 squared minus 1 and so on and so on and so on. But we want to find pi, not pi over 4. So what should we do to both sides?
Divide by 4. I mean, multiply by 4.
Yeah, so we multiply by 4. What happens when we multiply 2 by 4? What do we get? 8. And so here's a formula for pi. I'm going to write it on the next page. It's 8 times 1 over 2 squared minus 1 plus 1 over 6 squared minus 1 plus 1 over 10 squared minus 1. This formula, the technical term is, I don't know if I can say this. Can I say this?
Yeah.
Sucks. It's slow. It takes a long time. If you use one term, you get 8/3 or about 2.66667. If you use n equals 11, we get, and here's the exact fraction. I had my computer calculate this. I was not interested in doing that. About 3.096. Is that a good approximation?
Yeah.
It's okay. It's not great. If I use n equals 21, I get 3.11779.
Close.
If I use 31, 3.12, how does pi start?
3.14.
I'm not even getting the second digit with n equals 31. So I let my computer work for a while and I had to do 1 million. And I get 3.14159.215. Yeah, that's not bad. It's close to 3.14159.26535, but it's still a little bit off with a million terms. So this is a slow formula. And our goal is to find something a little bit better. So here is an introduction to trigonometry. So the big thing we need is the Pythagorean theorem. If you have a right triangle and you have sides A and B and a hypotenuse of C, then you have A squared plus B squared is C squared. So have you seen this before? Okay, so we're skipping simple grades for you. So when we're doing something like this, the first thing is, can you think of any triples A, B, and C such that A squared plus B squared is C squared? Okay, do you know any? 3.
Well, I was going to say a different one.
Yeah, 3 squared plus 4 squared equals
I
5
was going
squared.
to say 12, 13, 5.
5, 12, 13 is another one. So we're going to learn how to find all of these. So the first question is, why do we care about Pythagoras? So here's one of the reasons. It allows us to calculate distances. And I will tell you a funny joke, which is almost surely not true, but I like to believe it happened. So we can use the Pythagorean formula to find the distance between 2 points. So here's a nice grid. And you can see we go over 3 units to the right, we go up 4 units, And so by Pythagoras, 3 squared plus 4 squared is the hypotenuse. And so 3 squared plus 4 squared is 9 plus 16 is 25, so the distance is 5. So you know what the funny joke I heard about this was?
What?
Somebody was caught selling drugs in Manhattan, and the penalty for selling drugs is even more severe if you're within 1,000 feet of a school. And he was claiming that he wasn't within 1,000 feet of the school. He used Pythagoras, he was, but he said, this is Manhattan. Manhattan is on the grid system, and you can only move east, west, north, south. I can't cut through buildings. And so if I actually walk along the streets, it'll take a little bit over 1,000 feet to get there.
Is that true?
It is almost surely not true, but I thought it was a funny story. So this is a proof of the Pythagorean theorem. This proof goes back over 2,000 years. It draws lots of lines and whatnot. I always have trouble with this proof. This is the same proof, but they now put the stuff in colors. It helps me a little bit. And you can probably see, oh, the 2 oranges are supposed to be equal and the 2 reds are supposed to be equal. But I still have trouble with this. This one is just like modern art and is screaming at me and is making no sense. It's like, really, do I have to look at this?
Yes.
And when you look at this, it's how do they think to slice it this way to get all these different regions to show that they're all the same? So I want to show you a much better way to prove this. So I need to assume 2 things. The first is that you have a rectangle that's x by y, its area is x times y. So if the rectangle is 3 by 5, what would the area be? So what would the area be? And if it was 6 by 8, what would it be? 48. Now the next thing is, if I give you a right triangle, its area is 1/2 x times y. And here's the proof. If I cut the rectangle in half from diagonal, then the 2 parts are basically identical. I can flip one into the other. I can turn one into the other. And so if they have to add up to xy, and they're both the same, then each one has to be 1/2 xy. So here's the first proof of Pythagoras. So you take your right triangle, AB, and you put 4 copies. So how big, I'll ask each one of you, how big is this big side now? How long is the big side?
B plus A.
B plus A or A plus B. And now what's nice is this over here is a square on the inside. And if the hypotenuse is C, then the area of this square is just C times C, or C squared. I have 4 triangles. Each one of them is 1/2 AB. So the area is going to be C squared plus 1/2 AB times 4, C squared plus 2AB. But it's a big triangle, sorry, it's a big square of side A plus B. So its area is going to be A plus B times A plus B. And when you expand it out, and we'll talk about expanding it out later, you get A squared plus 2AB plus B squared. So if A squared plus 2AB plus B squared equals C squared plus 2AB, what can we cancel?
2AB.
We can cancel the 2AB, and we get A squared plus B squared is C squared. So this is going to lead us into trigonometry. Trigonometry is the idea of using angles and sides of triangles to figure things out. So this is my favorite proof of Pythagoras. So here's another version of it where I just shaded things in, and they said, here's another way to do it. Let's take the triangles and rearrange them. We'll put 2 of the triangles in the bottom left and 2 in the top right. And when we do it like that, then we have another way of showing that's A squared plus B squared equals C squared. Okay. Now, I am a professor at Williams College. One of the things I like is that we are famous for many things, including an alum, a graduate, James Garfield, who more importantly than becoming president of the United States of America, is credited with a proof of the Pythagorean theorem. Now, when you look at his picture, does that picture look like anything you've seen before?
Looks like a coin.
This part over here on the right.
It looks like the
It looks like the,
image you just showed us.
yeah, doesn't it look like just half of this, just drawing the line connecting this to that, going diagonally? But he is credited with his own proof. So here are 5 possible Pythagorean formulas. Okay. So I want to talk a little bit about which ones might or might not be true. Do you think the first one could be right? Do you think c squared could be a to the 17 plus b to the 17?
Probably not.
Okay, why not?
Because 8 to the 17 is probably like a lot bigger.
Well, let's try to think of units. What unit should we use for length?
W? I know.
We need to use a unit. Can you give me a unit of length? What might we measure units in?
Oh,
So that would
Centimeters?
centimeters. So if I give you centimeters, if I did something squared, what would centimeters times centimeters be? That would be
Centimeters.
centimeters squared. Do you think I could have a centimeter squared equals a centimeters to the 17th power?
yeah.
No. So that one is just wrong. The Pythagorean theorem can't look like that. For the next one, do you think it makes sense that it could be asymmetric? That it could be 17b squared, but only 1a squared?
No.
No. What about the third one, a squared minus b squared?
No.
What could be a problem with that?
Well, the C is the longest side.
The c is the longest side, and what could happen with a squared minus b squared? It could be,
Negative?
yeah, it could be negative. So there's a lot of things you could try for formulas. It turns out all of them have problems. The fourth one actually could be true. It's symmetric. It does still keep c as the longest side. It turns out to be false, but it is possible. So here, I'm going to give you another proof of the Pythagorean theorem because it's so important. Okay? So the area is a function of the hypotenuse c and the angle x. Okay? If I double the hypotenuse and keep the angle fixed, what do you think happens to A?
It doubles.
It doubles. And what do you think happens to B?
It doubles.
And so what will happen to the area? It goes up by
A power of 2.
4.
Yeah.
What if I triple C?
Then it will go up by an A will triple, a B will triple.
And so it goes up by,
Another power of 4.
well, no, if I triple
Oh,
C,
like 2 powers, like a power of 16.
well, let's think. If I triple C, A is up by a factor of 3, and B is up by a factor of 3. So what do you think will happen if A is now 3 times greater and B is 3 times greater? What do you think the area will be? How much greater? So draw your triangle.
Wait, what did you say?
So draw your triangle.
Should I know?
And if I now make A 3 times as large and B 3 times as large, how much bigger do you think the area is?
3 times.
Well, 1 time.
If you took your
By a power of 4, so
if
2
you-
times
if you
4.
took your rectangle, so draw a rectangle that's 2 by 3. And now draw a rectangle that's 6 by 9, so you triple each side. How much is the old area when it was 2 by 3? The area is,
6.
and how much is, so the area was 6, and how much is the area when it's 6 by 9?
Points.
54. How much bigger is 54 than 6? You have to multiply 6 by what? By 9. And 9 is 3 times 3. Let's draw another rectangle. Let's draw a rectangle that's 2 by 4. And let's,
Then it'd be,
and that would be it. Now let's draw one that's 10 by 20.
1 times 20.
Let's draw one that's,
Wouldn't it be like 6
by
by
24?
sure, let's, okay, do 6 by 24.
Wait, wouldn't that- No, it's
6
12.
by 12. And what's 6 times 12?
72.
72. What do you have to multiply 8 by to get 72?
9.
By 9. So if we triple the hypotenuse, we triple the 2 sides, and then the whole thing goes up by a factor of 9.
Yeah.
So the area is a function of the hypotenuse and the angle. And so we know that it has to look something like this. So the area is f of x, that means it's a function, and then we multiply by c squared. okay? So we don't know what that function is of x, but we know that it has to be like the hypotenuse squared. Where have you seen a formula before where you have something squared?
A squared plus B squared.
We've seen it a squared plus b squared, but we saw it someplace else. What was the very first shape we looked at?
A circle.
A circle we saw was the radius squared.
Yeah.
So similar to how a circle's area is something times the radius squared, a triangle, here's another way to find its area. Instead of just doing 1/2 length times height or 1/2 base times width, it's some strange function times the hypotenuse squared. Okay, and so now it turns out we need more right angles. So both of you draw a right triangle and figure out how can you create a new line that will give you more right angles. Where would you want to draw that line? From where to where? Yep, you got it. You both got it. So we draw the line from the corner to the top. And we will give these triangles really bad names, much worse names than you give your own kids. We'll call them triangle 1 and triangle 2, and we'll use Roman numerals because this goes all the way back to ancient times. Yep. Now here's what's interesting. So this little angle down here was x. This angle here, it's a right angle, it's 90 degrees. How much does the angles of a triangle add up to?
180.
180. So if this is 90 and this is x, so don't shout out the answer, how much must this angle be down here? Well, write it down on the piece of paper. Well, the whole thing is 180, so 180 equals so you have one right angle, which is 90. So simplify that. So one angle is 90, one angle is x, and then we have an unknown angle, call it y. And you need to solve for y. Yep. So what would you subtract from both sides? So if 180 equals 90 plus x plus y, yeah, and 180 minus 90 is 90. So 90 equals x plus y. Right, but we know what, but we want to solve for y in terms of x. So now we subtract x from both sides, and we get 90 minus x equals y. So if this angle down here is x, and this is 90, then down here is 90 minus x. So this angle has to be x as well. So that little angle is also x. So triangle 1 and triangle 2 both have an angle of x.
Which means they both have an angle of y.
Which means they also both have an angle of y.
And obviously.
And so when we're saying that area is some function times c squared, we know that they both have that same little angle. So we get that the first one, what is the hypotenuse of the first one? It's just a. So we get f of x times a squared. The second one is f of x times b squared equals
F of x
times c squared. Okay. What should we do? So don't shout the answer. What should we do now? We have f of x a squared plus f of x b squared equals f of x c squared. What can we do now to both sides?
4.
What should we do to both sides? We have f of x a squared plus f of x b squared equals f of x. Yeah. Now the only thing we have to be careful about is what is the one number you can't divide by?
0.
0. But if f of x was 0, then we would be saying that the area is 0. Does that make sense?
No.
No. So we can just get rid of the f of x, and we get a squared plus b squared is c squared. So this is another way to prove Pythagoras by using geometry.
Did Garfield do that for you?
No. This is a really good way that illustrates why it's sums of squares. Garfield was assassinated coming back to his Williams reunion. Since we're sent, I'm not sure why.
Was he president at that time?
He was president at the time. All right, so now we're going to do trigonometry. So we're going to introduce some functions you guys have not seen yet.
Is that a calculator this year?
Yeah, so they stand for cosine and sine. It is not sin, okay? It does not mean do something bad. So we're not doing sins. I know. They're called sine and cosine. So we're going to start off with a triangle with hypotenuse 1 and a right angle. And so do you agree that if I tell you what the angle is here, what the angle A is, and that the hypotenuse is 1, that the height and the base are uniquely determined?
Yeah.
So we're going to just call that height sine of A, and we're going to call that base cosine of A. We can just give them names. Now, how do you actually compute sine and cosine? These are very hard to compute. We can still just give them names. Names are easy, okay? So we're going to call the bottom cosine, and that's going to be the one that's touching A, the adjacent, and the one opposite A is going to be called sine of A. Now I'm going to make things a little bit harder. What if I change the hypotenuse to H? How much should the bottom increase by? If it was cosine A before, and the hypotenuse has been increased by a factor of 2, how much longer should the base be?
What you're asking?
Yeah.
2 times?
2 times. And if I make the hypotenuse 3 times as large,
3 times?
so if the hypotenuse is H times as large, the bottom should be
3 times?
Yeah. And so we would now see the bottom is H times cosine of A, and the top, the height, is going to be H times the sine of A. Another way to think about it is, imagine I'm measuring the hypotenuse in yards. I have the hypotenuse is 1 yard. Instead of using yards, I could use, instead of using yards, I could just say it's 3 feet.
Or 36 inches.
Or 36 inches. Or I could say it's almost a meter. And so the relative sizes of the sides don't change. So now here's something interesting. So here's my triangle. Here's 1, here's the angle A, cosine A, and sine A. Let's call this other angle up here B. So if I have A and B, what do you think this side should be in terms of B? So remember, we said cosine A is the side that's next to the angle, and sine A is the side that's opposite the angle A. But now my angle is B.
And it'd be like cosine B.
So this one up here, the height is now cosine of B, and what would the bottom be? And that would be sine B. So when A plus B equals 90, we've got this is cosine B, this is sine B. But this over here, this is sine A. So what does sine A have to equal?
Cosine B.
Cosine B. And what does cosine A have to equal? Sine B. So we've just shown that if A plus B is 90, then the sine of 90 minus A is the cosine of A, and the cosine of 90 minus A. So here's a plot of what they look like. And if you look at them, they do look like they're shifted by 90 degrees. So the top one is cosine. And when the cosine is 90, so when the angle is 90, the cosine is 0. And when the angle is 0, the cosine is 1. And you can see for sine, when the angle is 90, the sine is 1. They seem to be shifted off by about 90 degrees. Right, so now we're going to do equations of lines. Have you seen equations of lines?
Like rise over run.
Like rise over run. So there's many ways to write down the equations of a line. So this is a nice coordinate grid. So the most common way to write a line is called the slope-intercept. So we write y equals mx plus b, m is the slope, and b is the intercept. So the slope is if I increase x by 1, how much does y increase by? So if I change x by 1, how much does y go up? 2. So the slope would be, so the slope is how much y increases when x increases by 1. So the slope would be 2. The intercept is where does this line hit the y-axis? So when x equals 0, what is y equal to? So when x equals 0, where does it look like it hits? What value of y? And when you look at this, can you point, where does it look like it's hitting? Yeah, -3, so you got it.
So we can
this,
write our equation.
Yep, so the slope is 2.
Like y equals 2x minus 3.
So it would be y equals 2x minus 3. And so the last thing we need is it's called FOIL. First, outside, inside, last. This is how we multiply two different things. So if I have a plus b times c plus d, and I want to multiply them, I get a times c is ac, that's the first, times the first. And the last is the outside, which is going to be a times, oops, I did them the wrong way. I did them, oh, there's a typo here. That should be AD. That's a typo. That should be AD from outside. Then the inside is BC, and then the last is BD. So if I do x plus y times x minus y, this is fine. You get x times x. You get x times negative y, which is minus xy. You then get y times x, and you get minus y times y. Well, the minus xy and the yx cancel, and you get x squared minus y squared. So the one we're going to need is mx minus 1 squared. So you have mx minus 1 times mx minus 1. So why don't you multiply that out and tell me what you get.
Yeah.
So
mx is one number, right?
I'll do this one with you.
Like that?
Mx is one number. It's m times x. Mx minus 1 times mx minus 1. So the first is I do this times this. So I'm going to get mx times mx. Then I have the outside. It's going to be mx times negative 1 is going to be minus mx. And I have the inside, which is minus 1 times mx. And then I have the last, which is minus 1 times minus 1. What's minus 1 times minus 1? Negative 1 times negative 1 is 1. And so you see I have, this is going to be m squared because I have two m's, x squared because I have two x's. I have minus mx minus mx. So how many mx's do I have? Yep, I have two of them. So it's minus 2 mx plus 1. And so we get m squared x squared minus 2 mx plus 1. So now we're going to find all the Pythagorean triples. So we're going to find a formula to give you any a, b, and c, such as a squared plus b squared is c squared. So the reason we care about all of this is we can view a circle as it's all points that are a fixed distance from the center. So the easiest center to take is 0, 0. And if I want all points that are r units away, it would be x squared plus y squared is r squared. Okay. So if I have a squared plus b squared equals c squared, I can make things a little bit easier by dividing through by c, or by both sides by c squared. So I'll have a over c squared plus b over c squared equals 1. So do you know what a rational number is?
Yeah.
So what's a... Yeah, so an integer is numbers like 1, 5, 7, negative 12, 13. A rational number is a ratio of two integers, like 3/5, 1/7, 11/17, 3/2. So the first question is, I want you to take a circle, and it's all, we're going to do a circle of radius 1. So can you write down a point xy such that x squared plus y squared equals 1? Don't say it out loud, just write it down. Can you give me a choice for x and y such that x squared plus y squared equals 1? I think there's a couple, write it down. I think there's a couple of ones that are pretty easy to find.
So it's x plus y.
X squared plus y squared equals 1. So you have to give me a value of x and a value of y such that x squared plus y squared equals 1. So just write it down. Yep. So can you give me the pair x and y? Okay, so I've got one from you. Can you tell me what should x be and what should y be? I claim that there's 4 that are easy to find.
Oh, yeah.
So you've got 1. Can you give me another one? So 1, 0 is definitely good. 0, 1 is also good. There's 2 more. So can you give me another number that squares to 1? 1 times 1 is 1. Yeah. So you should put parentheses because it's negative 1 whole thing squared. And then put the parentheses before the 2, before the square. So, and then 0 squared plus -1 squared would also work. So these are the 4 points that are easy to find. There are other points, 3/5, 4/5 turns out to work. And the other points are the Pythagorean triples. So one of these points is actually really easy to work with. And the point that we tend to like to work with is the point 0, -1. And what we're going to do is we're going to draw a line going through 0, -1, and it's going to hit the circle at some point xy. And we want to look at all the rational xy where it could hit. So I'll do this a little bit fast. And so we must solve two equations. X squared plus y squared equals 1. That's the equation of what object? The circle. And we must solve y equals mx minus 1. So if you look over here, the y-intercept is -1. Okay? But we don't know what the slope is. So the slope can be any rational number m. Okay?
Except it can't be negative. Oh, yeah.
So
It can't be negative, though.
it actually could be negative.
Well, if we're starting
And if it,
0, negative
right,
1.
but then if it was negative, it would be going in this direction
that's
towards the
true,
left.
right. Yeah. that's
So remember how we calculated what mx
I keep
minus
thinking,
1's?
like, I know it's like go that
Right.
way. I just forget
And
at
that
first
is
every
that is
time that
possible.
go up. Like when I graph, I'm like, oh yeah, it can go up.
And so we have x squared plus y squared equals 1 and y equals mx minus 1. So we can substitute for y and we get x squared plus mx minus 1 squared equals 1. And remember how we expanded out mx minus 1?
Mhm.
When we expand out, we get x squared plus m squared x squared minus 2mx plus 1 equals 1. Oh, what can we do when we have that? What cancels?
What is it?
We have x squared plus m squared, oops, plus x squared plus m squared x squared minus 2mx plus 1 equals 1.
The one.
The ones cancel. And so now we get 1 plus m squared x squared equals 2mx. No. So we're almost done. So either, can you give me one value of x that works for 1 plus m squared x squared equals 2mx?
What, 0?
Yeah, 0. So
I
either,
figured 0 has
but see how
to work.
x multiplies both sides?
Yeah.
So we can get rid of that. Or if x is not 0, we can then divide by it. Okay? And we get 1 plus m squared x equals 2m. So we can solve for x. Okay?
Yeah.
And then we get x equals 2m over 1 plus m squared. Okay? And so I just want to see what page we're on. Oh, it doesn't show pages on this one. All right. And so we get y equals 2m squared over 1 plus m squared minus 1. And so when we simplify, we get m squared minus 1 over 1 plus m squared. So we're just doing some algebra now. So we have the equation of our point. So we get our point. Over here, the coordinates for x and y, it's just 2m over 1 plus m squared, and then m squared minus 1 over 1 plus m squared. And so this squared plus this squared equals 1. So if we multiply through by 1 plus m squared, we get 2m squared plus m squared minus 1 squared equals 1 plus m squared squared. So we've got one last thing, and then we'll stop. So we have one last thing to do. So I'm going to write m as p over q, and we get the following formula. 2pq squared plus p squared minus q squared squared equals p squared plus q squared squared. So we're going to stop after this. So here's pq, 2pq, p squared minus q squared, and p squared plus q squared. So I need a value for p. 1. And I need a value for q.
2.
Okay. So we actually want p to be larger than q. So let's do the other way around. Let's do 2 and 1.
Oh, 1 is 0.
So we have pq, 2pq. We'll stop after this. P squared minus q squared, p squared plus q squared. So we'll take p to be 2, q to be 1. And if you want, you take your own values of p and q and do this calculation. So calculate. So what is 2 times p times q going to be? Well, what's 2 times
I
2
just do
times
it
1?
with you.
4. What's 2 squared? And what's 1 squared? So 4 minus 1 is? So p squared minus q squared is 3. What's p squared plus q squared? What's 4 plus 1? We just found the triple 435. And so if you choose a bunch of different values, and then this is a good place to stop, here's a bunch of different choices for p and q. So for instance, if I choose p to be 3 and q to be 2,
6, 8, 10.
nope, I get the 5, 12, 13 triangle.
Oh, where were you? Oh, 3, 2. I thought you said 3, 1.
8, 6, 10.
8, 6, 10 works. And you can get that by choosing p equals 3 and q equals 1. So you can get every triple by choosing p and q. So you just go through all the different possible values of p and q, and this will give you every possible p and q. And this is,
I think you showed me this before.
yeah, it's really nice how this generates. So we will stop here for the math lesson for today, and then we'll do the trigonometry identities tomorrow, which is the more advanced part.